Okay, good morning all of you. Today we are starting with a new topic, that is I want to write this Ohm's law in the vector form. What is Ohm's law? I think it is very clear in your mind. Okay, Ohm's law says you that under physical conditions of temperature and pressure, that is your voltage is directly proportional to the electric current. So this is the Ohm's law. Now what we have to do, we have to write this Ohm's law in the vector form, and it is very important for this year. It is 1000% important, so surely you will get question from here. So let us start writing this in the vector form. So first of all, we know that current I is equals to I is equals to ANE VD. Okay, this is the formula for finding out the current. Okay, where this N is the number of electrons, A is the area of cross section, then this E is the charge on the electron, and VD is the drift velocity. From this we can change this expression by finding the value of this VD. So VD equals to I upon ANE. Now convert this VD, change this VD, write it. We can write it like this: I ANE. And we know that this tau is the relaxation time and A is the acceleration due to the drifting velocity of the electron. Now this A can be written as F upon M, and this tau equals to I ANE, and this F means this is the electrical force, so we can write E FQE upon M, and this tau equals to I ANE, and this E can be written as V upon L, and E M equals to, and tau is also here, equals to I ANE. Now just write it in another way. Just make V upon L as a subject. V upon L equals to V upon L. Shift this M this side, so M, I is already there, and A N E square. Okay, and this tau is also there. So this I upon A, is the current density, and this V upon L means this is for E, electric field intensity. This is E, and this is I upon A is the current density J, and then M E square N, and this tau gives me the specific resistivity. So this is the specific resistivity. That means we can write J, because we can write this is the specific resistivity, so it can be written in this way. So we can say this E is the vector quantity, and this J is also the vector quantity. So we get E vector equals to J and this rho. So this is the vector form of Ohm's law. We can also write this in another way in terms of sigma, that is in terms of electrical conductance. So J upon this sigma cross multiplied, so J equals to E tau. This is vector, so we can say that this J is directly proportional to electric field intensity. So this is the vector form of Ohm's law, and it is very important. Surely it will be coming this year. Now after this we are having electrical power and electrical energy. So electrical power, we can write power equals to W upon T. Rate of doing work is called power, and from here we can find out the value of this W. Okay, W is the electrical energy. We are having so many expressions. So W for finding the W, we can say W equals to VQ. So we can put this value here in place of W. So we can write VQ upon T. We can change this in place of V we can write IR, and Q can be written as IT upon T. T get cancelled, so we get I square R, and we can change this I also. This I can be changed as V upon, that means V square upon R square R. So 1 R get cancelled, so we get V square upon R. So we are having different expression. We can write it, we can obtain different mathematical operation expression for this power. So that I am not going in detail, because this thing you have done in class 10th. Now after this we are having one more important topic, that is the color coding of carbon resistors. Color coding for carbon resistors. And for the color coding, what we have to do, first of all, let me tell you, there are, suppose this is the carbon resistor, एक carbon resistor है, इसके ऊपर बेटा क्या होगा, there are 4 bands, 1 2 3 4 bands are there. These 2 bands represent significant figures. This gives a significant number, and this third band is for power of 10, and this fourth band is for tolerance. Okay, so that means these 2 bands gives me the particular significant figures. This gives me the power of 10, and this fourth band gives me the tolerance of this carbon resistor. For understand it in a better way, what we have to do, first of all, let us write a statement. That is BB let us write it here. BB B Roy of Great Britain visited Gateway of India. So this is the statement I am written here. Now here these alphabets, these first alphabets of every word represent a particular value. For this B gives me 0, and this gives me 0, and then second B gives me 1, and then this R is for third number, then this O is for fourth, and then Y is for the fifth number. Then we have 0 1, this is 2, sorry, this is 2, this is 3, and this is for 4, and then this G for 5, then this B for 6, then this V for 7, and then this G for 8, and then this W for 9. So these are the numbers, and this B 0, this B 0, and this B also denote a particular color. This first B for black, then we are having this B for brown, then we are having red, then we are having green, okay, then we are having blue, then we are having 7 for violet, then we are having this G for green, G for gray, then we are having a white. Okay, so they represent colors also, and they represent a particular value also. Now see here the carbon resistor. Now suppose this is of say red color, say this is of brown color, and this third is say the brown, then this third is for say green, and say this is white. Okay, so these are the colors which are given. Now see, these two bands represent a significant figure. So R, red. Now check for red. Red is here. Red means this R, so that means 2. So right here 2. Second is brown. So check for brown. Brown means it is for 1. Then check for the third band. Third is for power of 10, and it is of green color. Now say green, G is for green, and then we are having white. Now for the fourth band represent tolerance, and if it is the color is golden color, it means tolerance is 5%. If the color is silver, the tolerance is 10%. And if color is white or no color, then tolerance is 20%. So we are having a white color. So white color means it will be plus minus 20%. So in this way we can find out the resistance of the carbon resistors. Okay, I will give you few questions regarding this, and it is very important topic. So please just go through the topic. Okay, and I send you some questions. Do those questions. Thank you very much.